This is the 10th VCF East. I hope we're doing okay. Cool. Last year was the first day we had Friday, and this year we have about 150% people on Friday versus we're pondering the idea of next year, maybe do like instead of classes, maybe do a hackathon, a vintage computer hackathon Friday. That'd be kind of cool. Just an idea. Anyway, enough about VCF. So, this is a really special computer. Does any of you not know what a PDP-8 is? Bill. Okay. Oh, you seriously don't? Okay.
Alright, so somebody else help them.
Okay. Bill's just being smart. Okay. So, this is a mini computer. And why is it called mini when it's so big? It was mini compared to what came before. Right? And it's by a company called DEC, Digital Equipment Corporation, which in the 90s was bought by Compaq, which was bought by Hewlett-Packard in the 00s. PDP was the series, and that programmable data processor. There's sort of an urban legend that DEC didn't call it a computer because that would scare people off. I don't know if that's true or not. Anyway, okay. They say it's true. So the term mini computer, I don't know who coined it, but it kind of came into being in the mid-60s to represent this smaller class of computers. You no longer had to rent time on the mainframe somewhere else. Anyway, the PDP-8, there were many series of PDP-8s, but this is the first generation of the PDP-8 in 1965. And it was more or less the first computer that a regular company could afford. It was about 20 grand in 1965, so about 100K today, right? So like one engineer's salary, you know, a reasonable amount of money for a company back then. And they only made 1,500 of these. By the way, I think this is number 1196 or something like that. We tried finding out how many were desktop, how many were rack mount. We asked Gordon Bell, who was the head designer, and he said, you guys probably know better than I do at this point. And he sends his apologies he couldn't be here today. He's been at VCS before in California. He's traveling this month. He had it planned long ago, so he sends his apologies. He wishes he could be here. Anyway, this particular PDP-8 has an incredible backstory. This particular one was given as surplus to a high school computer club in central New Jersey in the mid to late 60s. And it was unheard of for a high school computer club to exist back then. Kids weren't supposed to have computers back then, let alone a one-generation-old machine, you know, that was worth so much money. That club got to be kind of famous because it was written about in Ted Nelson's book, Computer Liberation and Dream Machines. Anyway, so Claude Kagan was the engineer who ran the club. He passed away a few years ago, but before he did, he gave us the computer. It was literally in his barn. And Claude was legally blind. And he lived kind of in a backwoods area. So when we got it, it was a whole different color. We found mouse remnants. We found a beautiful, well-constructed mouse nest. We did not find the mouse. It came with a plotter. So my joke is, you know, it came with a mouse and a graphical interface. Thank you. I'll be here every night. Anyway, it was in disrepair was the understatement of the year. It was in horrible condition. And we all said, maybe someday we'll restore it, but it just wasn't realistic at the time. None of us had ever restored such a computer. So we cleaned up as best we could, which was like a 20th of how it looks now. Stuck it in our museum and told people the story of its background, and that was kind of it. Two things happened a few years later, kind of at the same time. Claude Kagan passed away in his 80s, I guess. So we had a memorial service for him here, and it wasn't really a service, it was just a memorial where people who knew him at different points of his life all came here and we honored Claude. And the high school computer club we had, by the way, in the 60s was called RESISTORS. It was radically emphatic students interested in science, technology, and other research subjects. Claude was an eccentric man. He had a unique lifestyle, way ahead of his time. And so, anyway, Claude passed away, so we had a ceremony to honor RESISTORS. And a funny thing, Claude told us when he gave us the computer, oh, I checked with the student alumni, they're cool with it. And the resistor said, this is the first we're hearing of this to give you the computer. So it kind of gave impetus to us, you know, it's really time to do what we said we would do and restore this thing. Around the same time, David Guesswine, one of our members, David, got his own PDP-8, which is hard to do. And he restored his because he had restored a lot of other slightly newer PDP-8s. We said, okay, the things are colliding here, it's the right environment to restore it. David took it home with him to DC last year after VCF, or a few months ago, whatever, and restored it. It's almost working now. So what we're going to do is, that's the story of the computer. Andrew here is here representing the resistors. He was one of those students. And he's going to talk for 15-20 minutes about the club and how they used it and everything. And then David is going to talk about how he restored it. And I guess the three of us will have the honor of the ceremonial first power on. Hopefully we won't have a first to smoke today. Andrew, the floor is yours.
All right, thank you. My name is Andrew, and I'm a recovering resistor. I became a resistor in 1967, probably about a year after it had formed. And at that time, we didn't have the PDP-8. We were working on vintage computers then. One of the vintage computers was a Burroughs 205, which was enough cabinets to fill up this space. The logic was relays and vacuum tube logic. On a day like today, we could not run that machine because it would risk burning the barn down. It ran through 90 cents worth of electricity every hour. And one of our preoccupations, of course, was figuring out ways of paying for the electricity. That was a lot of fun. We also had a Packard Bell 250, which was a solid state machine, thank goodness, but its memory was acoustic delay lines, which had the disadvantage of losing everything in the middle of a thunderstorm if the power went out. So I learned, one of my first lessons as a resistor was, don't even bother programming it during a thunderstorm. Forget it. So, now my part in this story is my family relocated with me to New England in the summer of 1967. And the following year, the year of my graduation from high school, I got myself a job as I think they called it programmer trainee at the digital plant in Maynard, Massachusetts. And Claude, ever the opportunist, recognized that he could probably finagle a computer from Maynard if he had me go around and introduce the resistors to key people in Maynard. And it worked. What was it, the year that the computer conference, what was it, the Spring Joint Computer Conference was in Boston, I think that was '69, the computer was donated to the resistors, and they all, a bunch of, half a dozen or so resistors came up to claim it from Maynard, and the first thing we did was try to run it in my garage, which was not successful because the power integrity in my neighborhood was not good. And every time, I think it would lose consistency of everything that was going on if we had a spike. So we moved it on to its next that next destination, which eventually was the barn in New Jersey. Now, that's all I know about this PDP-8 because, it was in New Jersey and I was in Massachusetts. So I think that's where I'll leave this story because I'm really interested in hearing about the restoration.
Great, thank you, Andrew. The wooden platform that came on from DEC, we still have, and we just used to move on a rolling cart today. When we had a memorial a few years ago for Claude, Andrew and all the other resistors signed the wooden platform. So when it goes back into our museum after the show's over Sunday night, it'll go back on that. So.
Hello, I'm David Gesseline. I did most of the restoration on this. Corey Cohen did the final painting since he knew the technique. Corey, what did? That slide was visual, but looks like we're not set up for them. So stop by the booth and you can see the pictures. I guess we pretty much covered most of this. Like the machine was stored in a barn in an uncontrolled environment for basically its entire life. It did have a plastic cover over it, which helped, but still it had significant corrosion and other stuff has been discussed. This one appears to have been made late 67 or early 68 based on the date codes. So I picked this up to start the restoration in October of last year. I have been much more familiar with electrical restoration. I tend to go for, if it looks worn, but like it would have been as it was used, I normally don't try to make it back to as new condition. I do want them to be functional. This one was way past worn. So,
everyone remembers my discussion this morning, when you make a decision and restore or just clean up. This was restore.
So, the machine was entirely taken apart. All the metal frames were taken out, sanded down to bare metal, primed, and then painted. And one thing I always find in these processes is no matter how many pictures I take when I'm disassembling it, so I'll know how it goes back together, you never have the critical shot for where did this piece really go.
We have extra parts, David?
Yes, we do. We'll get to that a little bit later.
Tell me
The power supply is down here in the basement, in the bottom, which being on the bottom, it caught the worst of the stuff, and that's where the mouse was. So that also had completely taken apart. So we also have the big capacitors that are in there, which everybody debates on what the right way to do with them. If the components are still good, I leave them alone. So I did a full test reforming, where you slowly bring up the voltage at a limited current, and then I measured the ESR, the capacitance, and so on, and the capacitors all met reasonable specs. I don't actually have the data sheet from these old capacitors, but they were all reasonable. So I retained them. There is one issue with them. There is some cracking around the terminal where the aluminum is corroded, which may make a long-term issue with it. If I open the seal, there's a liquid electrolyte in them that it evaporates, will make them go bad. So we will need to monitor them. The easy way to monitor them is just measure the ripple periodically. If the ripple's starting to get worse, then you know you have a capacitor going bad. So I separately bench tested the supply away from the machine, since you never want to attach an unknown supply to your electronics. And while doing that, I found in there was a crimp terminal that was poorly crimped, that somebody then had tried to solder to fix the crimp, but they didn't get it hot enough, so the solder had never really flowed. So the terminal still spun on the wire. So I did a better solder job on that. There's several types of capacitors. The aluminum electrolytics are the big ones, and there's a couple other spots. There's hermetic tantalums, which are quite reliable. There's a mil-spec type. This one doesn't have any. Another really trouble-prone capacitor is the dip tantalums, but luckily it only has the other type, and it has a couple electrolytics, the little smaller ones in the back lane. One of them was bad that I had to replace. And it also has in the power supply for the ferroresonant transformer. Most of the power isn't really fully regulated electronically. There's a weird technology with transformers. You can regulate voltage, which is called ferroresonant, and that's what this uses. Those have an AC oil-filled capacitor, which in this time frame is PCBs, which was super fun clean-up time. So that was removed because they tend to go bad, explode, and spew boiling, contaminated oil around, which is not a good thing. Then I also pulled the back planes out. They were all covered with stuff, so I washed them. I tried to inspect the terminals where the cards plug in. I was unconclusive on how bad the corrosion on them was. On past machines, normally just cleaning the cards and reseating them, they seem to be reasonably reliable, although it is a gold tin, which is not a recommended combination. You're supposed to either gold-gold or tin-tin. But on the DEC machines, it actually seems to work reasonably well. On this one, I have found on some of the slots where I've had intermittent connections. I guess I don't have it open. At the bottom of the back plane, there's what's called margin switches, which you have this variable voltage control. And what you would do on the machine, they were a lot more flaky back then. So you would periodically run them intentionally at reduced voltage, and there's a switch for each row of cards to be able to apply the reduced voltage. And that way you could find ahead of time a card that's starting to go bad. And then you could repair it before it failed during your actual usage. All those switches were in horrible shape. Most of them I couldn't even actually flip. And some of them had like 50 ohms resistance, which trying to power the computer through would not work well. So I took all of them apart and cleaned them up. That's really a toss-up on whether it's better just to replace them all, because it's a lot of time to do that. Although finding white switches like that, you don't have a huge choice. And then all the cards were taken out, washed, and inspected. That was another thing that I probably should have done a little differently. Is on my machine there were about 15 cards that I had to repair. This one I have either repaired or changed, swapped out the card for 53 of them. So I should have, while I had the cards out, gone through and tested all the components that were easy to check with simple meters. Although that did mean checking about 10,000 diodes if I'd done that. So it was a toss-up on which was going to be longer. Then worked on the front panel. There were two dead bulbs. One of the switch handles, there's little plastic pins that hold the switch handles on. Had a broken pin, which just drill out and put a metal rod in. It's an easy way to fix that. The power switch was missing some of the plastic pieces in the switch itself, so I made reproductions for that. And the deck also had some interesting things on AC wiring. This machine had a 10-gauge power cord, has a 20-amp breaker, internal wiring is at best 16-gauge, going to a 7-amp switch for all the current runs through. And there also is a reasonable amount of exposed AC that you can get your hands on when these back planes are open. So they weren't quite as big on UL codes, I think, back then. And then when I put all the cards back in, I checked against my print set to see how everything goes. It's always a challenge with these because DEC made changes throughout the life of this machine. So you're never sure whether your documentation matches the machine you have on hand. But there were 3 cards that seemed to make no sense according to my documentation. And I checked the wiring, and it made no sense for those cards to be there. So yes, I have leftover parts. There are 3 cards that I don't think ever should have been in this machine. The cards also were missing a couple components, so I think those were just extra cards that were around that somebody just shoved in the backplane. And there are also like 1 or 2 cards that weren't in the right spot. There was 1 card missing that will only be needed if we hook up an external peripheral to it. This machine has 4K 12-bit words of core memory. Is in the box up at the top there. I took that box out of here during the cleaning, and I put it in my machine so I could attempt to read the memory contents and see what was the last left in this machine when it was last used. And I was reasonably successful. My machine also apparently, the front panel is getting a little flaky, so it overwrote a couple words. But what I found in there is there was a program to punch the memory contents to paper tape that looked like for dumping when you're done, so you could reload it later. There's the standard optical debugging technique debugger, the 2 loaders that are used to load paper tape, and at 200, which is a common address for programs, there was a program in there that looked like it was intended to print out "computers are shit." Although they were either some of the memory had gotten corrupted, or they never finished debugging it, which is maybe it was expressing their frustration on trying to deal with programming these machines. So then I put the whole machine back together, and then always the scary moment is when you have to power the thing back up. Luckily, nothing exciting happened. So, we got lights on the front panel, so tried front panel operation, and got a little signs of life out of it, but not much was working. So then it's just the slog on through, finding the electrical faults. There's an annoying failure mode that on this, which this is diode transistor logic, which probably doesn't mean much to too many of you, but most of the logic is done with a diode. And the common failure mode is the diode goes leaky. But that means it's the load card where the destination of the signal is going to that's actually causing the problem. And there's no wireless, and the schematics don't have cross-references, or so you have to just search the schematic to figure out where the signal goes, so you know every card that you need to look at, which is why just checking them all the cards before I put it in here probably would have been a better idea. And like I said, I had another one of these machines for a reasonable amount of the time. I was cross-checking between the machines if I saw something funny that I wasn't entirely sure how this should behave, or I'd borrow a card to see whether it's really this card. After some point, I had enough cards borrowed from my machine that it was too much of a pain to swap them back to run my machine again. So I have a bunch of cards I still need to repair to get my machine. I'll repair them, put them back in here. Anything with a little piece of masking tape on it is one of my cards. So. The other interesting thing I found, there's an analog to digital converter option installed in here, but the wires that disable that option are also still in this machine, so it doesn't actually work. So I don't know whether they got the cards late and put them in, but never actually got them working, or what was going on there. And the notation used on the schematics is obsolete or DEC specific, so it's we got a little learning curve to even be able to read the schematics for this machine. There's one of the cards that has some delay lines for the memory circuitry that are these epoxy encapsulated basic LC circuits to do delays. Those appear to all be going bad. So right now it has my cards, and we need to think on the best way to deal with that. We may have to try to figure out whether we can get a current delay line to replace those. Okay, so 39 boards have been repaired, 14 have been swapped. So far I've replaced 41 diodes, 17 transistors and 1 capacitor, not accounting for my OPSs. While I was reforming one of the capacitors in the power supply that was soldered in and did not look like it wanted to desolder without using way too much heat and so on, I actually bumped a wire that pulled another wire that then hit the capacitor and bye-bye the transistors. There was only a couple parts left in the power supply. Almost all the wires are disconnected, but of course the wire that has to move is the one that can do the damage. So the status is, like you see, it looks much nicer. I have managed to run focal for a little while. Most of the diagnostics have passed once. But right now it tends not to last in that state. So I think we probably still have some more bad backplane contacts, and some of the components I think are still failing. So it's probably going to be a while before it will really be reliable. So we will see after hauling it 4 hours on how well it actually still works. And I did notice that there's evidence while I was going through here that there have already been a number of repairs made to this machine based on the flux residue and damage to pads or something when they had done the repair previously. So it was not entirely reliable even when it was new. And like I said, there's a couple other issues. That the diodes are glass encapsulated, and there's a bunch of them with little chips out of the glass. I don't know if that's due to the corrosion stressing the glass, so it's unclear on whether that's going to derive the failure of components. Like I said, they're looking into new plastic covers. Some of the paint on the front panel is deteriorated. I don't think we made any decision on what we're doing on those. The front panel switches, all I had time for was use contact cleaner. So I've actually made a little mod and added some extra capacitance on the debounce circuit. So the switches that are not working quite as well as they used to when new, the machine still now will operate okay with them. If we do more work on the front panel, we may want to do some more work on the switches. This, like I said, came with a plotter. Based on some old photos, there appeared to be some more racks of these cards that was the interface to it. That appears not to exist anymore, so we may need to make an interface if we want to run the plotter again. And I think that's about all I have to say.
So David's going to make a little web page, right, to summarize all this. Yep. And that should be up soon, I guess. And we'll update it over time. So since the original was in a barn, we thought the best way to recreate that in 2015 was a wet, outdoorsy kind of tent. What a great place for a power-up test. So, what do we do, David? Okay. Is there a big red lever? Plug it in and start. And so we have power in the building over there, outdoors to a consumer-grade $5 power strip. So it seems pretty safe.
Where's the fire extinguisher?
Right behind you.
Okay.
Yeah.
Get ready, Bill.
These are in this template. The biggest collection of X64
It's fun for some of the younger people to have a computer you can actually start with a key. Okay. Here goes.
Funny looking. You got any masks?
Get ready.
There appears to be no power there.
Is there
Chip is on because,
Is that on?
no, maybe the chip is on. Not plugged in on your end.
There we go.
Away.
Yeah.